Hello students, this is Dr. Nitaraj, your chemistry mentor, welcoming you for another session in electrochemistry. Today we are going to see an important secondary cell, that is a lead acid storage cell, right? See, first we shall see what are secondary cells. The cells which can be recharged by passing a direct current through them are called secondary cells. So of course, after every use they can be recharged and thus can be used again and again. Okay, and these secondary cells or the storage cells or otherwise called as accumulators or repeated action cells. Okay, so from the name itself we can understand that it can be used again and again. Okay, why they are called as storage cells or accumulators? Because they are capable of storing electrical energy in the form of chemical energy. Okay, so that's why they are having the names storage cells or accumulators. Okay, so we have some examples under this category. They are the lead acid storage cells and nickel cadmium cells, and still we are having so many other examples also. Okay, so first we are going to see about this lead acid storage battery. See, actually it is a galvanic cell. What do you mean by a galvanic cell or an voltaic cell? It means it converts the chemical energy into electric energy. That's why it's called as a galvanic cell. Okay. So first let us see how it is constructed, how this lead acid storage battery is being constructed. Okay. So let's say here this lead acid storage battery is made up of a grid of lead which is packed with finely divided spongy lead. Okay. See here it is made up of a grid of lead. Okay. It is made up of a grid of lead which is finely packed with a spongy lead, or else it is made up of an alloy of lead and antimony. Lead and antimony are mixed together to form an alloy and it is used here. Mostly we make use of a lead which is finely packed with divided spongy lead. Okay, that acts as the anode. Okay, so that acts as anode. And now the next one, cathode, is a grid of lead coated with a reddish brown lead dioxide, PbO2. So the next one is a lead dioxide. This acts as a cathode. Okay, so PbO2 acts as cathode. So this cathode is a grid of lead coated with a reddish brown lead dioxide, that is PbO2. PbO2. Understood? So anode is made up of Pb and cathode is made up of PbO2. And the next comes the electrolyte. Electrolyte is an aqueous solution of sulfuric acid having a density of 1.3 gram per liter. So these two types of electrodes, that is anodes and cathodes, are immersed inside the electrolyte, which is nothing but sulfuric acid. Okay, it is nothing but it is sulfuric acid. And what's the density of the sulfuric acid? It is 1.3 gram per liter. Understood? So as mentioned above, this lead acid storage battery is constructed by connecting a number of lead acid storage cells in series. Okay. See here, this battery consists of 6 cells. Okay, this battery lead acid storage battery consists of 6 cells, and these 6 cells can provide 12 volts. Okay, it can give an EMF of 12 volts. So in order to obtain an EMF of 24 volts, we should connect 12 cells. Okay, 12 cells to be connected in series. Okay, see, in a lead acid storage battery, the anode and cathode plates are arranged alternatively. First anode and then cathode. First anode and then cathode. Next anode and cathode. Okay, and these are separated by means of an insulator. It is separated by means of an insulator. See here, the anode and cathode plates are separated by means of separators made of insulating material. See here, it is clearly shown here. This is anode and this is cathode, and both these electrodes are separated by means of insulator. Okay, a separator. Understood? And these anodes and cathodes are alternatively arranged and are immersed in a bath of 38% solution of sulfuric acid. Okay, the container is made up of a tough material. Okay, this is also made up of a tough insulating material, and these electrodes are separated by means of insulators or separators. Okay, so the anode and cathode plates are separately connected to one another. These are separately connected. All the anodes are connected together and all the cathodes are connected together. Understood? This increases the surface area of the electrodes and hence the current producing capacity of the battery also enhances. Can you understand? Why? And now we shall see the cell representation. This is how always the anode will be represented in an electrochemical cell or a galvanic cell or an voltaic cell. always the anode will be placed on the left hand side. Okay, the left hand side, anode will be placed on the left hand side. Next comes, see here PbSO4. Why it's written PbSO4? Because while discharging, PbSO4 will be getting deposited over Pb. Okay, over anode. That's why PbSO4. Next comes electrolyte. Next comes cathode, PbO2, and here it is coated with Pb. Okay, so cell representation for lead acid battery, and this is important. Okay, sometimes you may get this for 2 mark questions even, right? Now we are moving into the important part of this lead acid storage battery, that is working. Okay. See, under working we have two sets of reactions. One is a discharging and another one is charging. Okay. So what happens during discharging? That is when the battery is operating. When lead acid battery operates at the anode, lead is oxidized to Pb2 plus ions and an insoluble PbSO4 is formed. Can you understand what I have written? See, during discharging, the anode lead plates will be undergoing oxidation to form Pb2 plus ions, and an insoluble PbSO4 is formed over this lead plates. And at cathode, what happens? PbO2 is reduced to Pb2 plus ions again, and then PbSO4 is formed over that also. So in both anodes and cathodes, PbSO4 coating will be formed during discharging and current will be dissipated. Okay. So let us see how the reaction takes place. Okay. Now we are moving into the cell reaction, right? So let us see the cell reactions. First we will see the discharging part. During discharging, what happens? First the electrolysis of sulfuric acid takes place. Okay. The electrolysis of the sulfuric acid takes place. The sulfuric acid undergoes decomposition to form H plus ions and sulfate ions. This is more important. Okay. So how many H plus ions will get? 4 H plus ions and 2 sulfate ions. This is the first step. This is very important. Okay, sulfuric acid undergoes decomposition to form 4H plus 2 sulfate ions. Now let us see what is going on in the anode. So anodic reaction. In the anode, Pb, that is the anode, that is this electrode, it undergoes oxidation. That means it gives 2 electrons and it forms Pb2 plus. It undergoes oxidation and it forms Pb2 plus. Okay. Always oxidation takes place in anode in an electrochemical cell, in a galvanic cell. So it is, since it is giving 2 electrons, it forms Pb2 plus. Now this Pb2 plus, it accepts one sulfate ion. It accepts, there are 2 sulfate ions. It accepts one sulfate ion and it forms PbSO4. This Pb2 plus, it will not remain as such. It accepts sulfate ion SO4 2 minus and it forms PbSO4. Now let us write the overall reaction here. See, Pb2 plus and Pb2 plus gets cancelled. You write the rest. Pb plus SO4 2 minus gives PbSO4 plus 2 electrons. Is it not? Pb, this SO4 2 minus PbSO4 2 electrons. So this is what taking place in anode. This is anodic reaction. Let us see the cathodic part. What happens in the cathode? Okay. Let us see what happens in the cathode. See, in the cathode, this PbO2. What is cathode? PbO2. Is it not PbO2? This PbO2, it accepts. See, already see, it accepts this 4H plus. Okay, it accepts 4H plus and also one more sulfate ion is left out. Okay, one more sulfate ion is also left out, and also it accepts the 2 electrons released by this anode. Can you understand what is happening in cathode? Cathode, this PbO2, it accepts the 2 electrons released by this anode and also it accepts the 4H plus ions along with SO4 2 minus. Okay, so what is happening here? It accepts 4H plus SO4 2 minus plus 2 electrons released by this anode, and finally it is giving PbSO4. Okay, it is forming PbSO4 plus 2 molecules of water. Okay, check whether the reaction is balanced. Here 4H, here also we are having 4H. how many oxygen here? 4 plus again plus 2, 6, is it not? So here 4 plus 2, 6. So it's balanced, okay? Let's solve it. Now see the cathodic part, anodic part and the cathodic part. Now let us write the overall reaction. Now let us write this is the anodic reaction. This is the anodic reaction. Is it not? This is the anodic reaction. And this is the cathodic reaction. Now we are going to write the overall reaction taking place during discharging. Okay, we are going to write the overall reaction taking place in the during discharging. Now we are going to cancel that are in common on both the sides. Okay, so here two electrons on the opposite side. Just check what are the things that are in common in the opposite side. Here two electrons, they are same, is it not? So we'll cancel. Okay. Then what else in common in the opposite side? No, nothing is in common. PbSO4 here is on the same side. So we should not write. Okay. So let us write the rest of the thing. Pb, we'll write Pb plus PbO2. Is it not? Pb plus PbO2. Then 4H plus 2SO4 2 minus. Okay. Plus 4H plus 2SO4 2 minus gives 2 PbSO4. Am I right? 2 PbSO4. 2 PbSO4 plus 2 molecules of water. 2 molecules of water. Okay. Now check here the Pb is converted to PbSO4. PbO2 is also getting converted to PbSO4. Sulfuric acid, it's been used up and we are having only water molecule. So this is what happening, but we'll be getting energy. Okay, along with that we'll be getting energy. Okay, that means chemical energy is being converted to electrical energy. This is what happening during discharging. Okay, so from the above reaction, it is clear that PbSO4 is precipitated at both the electrodes in the anode as well as in the cathode, and sulfuric acid is being used at. Okay, so concentration of the sulfuric acid decreases and hence the density of sulfuric acid falls below 1.2 gram per liter, because in the beginning it was 1.3, is it not? So now at this moment this battery has to be recharged. Okay, it should be recharged because everything ceases. I hope you can understand what I mean. See, this electrode reaction as well as the overall reactions clearly indicates that the sulfuric acid gets used up during the discharge of the cell. Therefore, when current is drawn from the cell, the sulfuric acid gets diluted and its specific gravity falls. So both the electrodes are getting coated with white precipitate of this lead sulfate. Okay. So when the specific gravity of sulfuric acid falls below 1.2 gram per centimeter cube and both the electrodes are getting converted to lead sulfate or getting covered with lead sulfate, the cell reaction stops. Okay, the cell stops working and it has to be, at this moment, it has to be recharged. So at this stage, the cell or the battery needs recharging. So next we are moving into the recharging part of this battery. Okay. See here what's happening during recharging. When lead acid battery is recharged by passing electric current, the electrode reaction gets reversed. Just it gets reversed. Okay. So let us how the battery is recharged. The discharged lead acid storage battery can be recharged by passing a direct current through it in the opposite direction. That is, for this purpose, this negative electrodes of the storage cell is connected to the negative part of the DC source and the positive electrode of the cell to the positive of the DC source. Okay. So the direct current thus passed reverses the electrode reaction, and as I told you earlier, the complete anodic reaction and the cathodic reaction will be getting reversed. Let me write and show you what is happening in the anode. See what's happening in the anode. So just you want to reverse the reaction. PbSO4, when you are passing electricity, the lead sulfate coated getting a reverse mean this will be getting converted to lead plate. Okay, so Pb plus SO4 2 minus. Okay, and what is happening in the cathode? Just the a reverse reaction. Okay, just we want to reverse this. We want to reverse this reaction. Okay, so let us reverse this reaction. PbSO4 plus 2H2O. Okay, now it gets reversed to PbO2 plus 4H plus SO4 2 minus plus 2 electrons. Okay. So now let us see the overall reaction. Let us see what is happening during a recharging overall reaction. Let us cancel those things that are in common. Two electrons in common. Is it not? So cancel it. Cancel here. What else in common? Nothing in common. Is it not? So let us write here the overall reaction. 2PbSO4 2PbSO4 plus 2H2O gives Pb plus PbO2 Pb plus PbO2 plus 4H plus 2SO4 2 minus 2SO4 2 minus. See here, we have got back the lead plates, replenished PbO2, and we have got the sulfuric acid back. Is it not? So we have got the anode and cathode, and also we have got the sulfuric acid back. So from the above reactions, it is clear that during recharging of the cell, the electrode materials are restored in their original forms. Is it not? So due to the formation of H plus and SO4 2 minus, the specific gravity of the sulfuric acid also increases and it attains the original value, that is 1.3 gram per liter. Okay. The cell generates electric current till it again gets discharged. So the cell thus becomes ready for the fresh usage. Okay. Hope you have understood the main part of this lead acid storage battery, that is just discharging and recharging. Okay. Now let us see the usage, and actually it is used to supply current mainly in cars, buses, trucks, etc. And also it is used in gas engine ignition. Okay. In telephone exchanges, in hospitals, in power stations, and also in inverters. Okay. What are the advantages of this lead acid storage battery? See, actually it can be made very easily, right? And it produces very high current. It can be made very easily. It produces high current, okay, it produces high current, and then it also acts effectively at low temperature. When the temperature is very low, also at that time also it can be used very it acts very effectively, okay. And the self discharging rate is low when compared to other rechargeable batteries, okay. So when you're taking into account the disadvantages of this lead acid storage battery, see, while recycling of this battery, it causes some environmental hazards. Okay, it causes some environmental hazards. Okay, and well, fine, students. I hope you might have understood what I have taught today. Let me meet you with another important topic in my next session. Until then, it's Dr. Anita Raj, your chemistry mentor, signing off from you. Thanks for watching.